Okay, I make it 8 o'clock, and good morning, everybody. I'm going to hand over to Yiping Lu, who will introduce himself, and he will be leading the first half of the session. My name is John Innes. I'm from the University of British Columbia, and I'll be leading the second half of the session. So, Yiping.
Thank you, John. Thank you. Open the session. It's my great pleasure to work with you to chair this session of the third day of the conference. So in this session, we will have 6 speakers. Followed with this, we will have a panel discussion. The time is about half hour for the panel discussion. So I will help the first 3 speakers, then John will chair the second part. So it's my great pleasure to introduce our first speaker, Professor Zhou and his team. Professor Zhou Gumo works in the Zhejiang Agriculture and Forestry University of China. He has been long engaged in research of the forest carbon sequestration mechanism and capture capacity in past 20 years, especially on bamboo forest and products. He has gathered numerous knowledge and information on bamboo carbon. Also, his team developed a bunch of technology in carbon measuring and monitoring. For example, the carbon methodology developed by the team has been accredited by the Chinese government and applied in carbon projects. So in this meeting, Dr. Tingting Mei will give the presentation on behalf of Professor Zhou and his team. Dr. Mei is one of the key members of the research team led by Professor Zhou. She holds a PhD degree in forest ecology from University of Göttingen, Germany. She has been working on bamboo water use since 2008 and the carbon water coordinated mechanism on bamboo since he joined the university in 2017. So it's my great pleasure to invite Dr. Tingting Mei to give the presentation. Dr. Mei, the floor is yours.
Okay. Thank you, Dr. Lo. Thank you for introducing myself. And I'm going to share my screen. Okay. So. Okay. Good morning, ladies and gentlemen, and good evening, colleagues and friends from Asia countries. I'm Tingting Mei from Zhejiang Agriculture and Forestry University. Today, I'm going to talk about carbon stocks and the footprints of bamboo products. The original idea of the presentation was provided by Professor Guomo Zhou, and his group members conducted the main work. I will try my best to convey his ideas as precisely as possible. Okay. Many studies have indicated that the bamboo forest is a significant carbon sink, which is mainly attributed to its high carbon sequestration ability. Due to economic need, only in China, up to 2.35 billion tons per year are harvested and used for bamboo products. This makes the bamboo product a potentially significant carbon pool. To explore the low carbon level of bamboo products, we studied carbon stocks and emissions during the production process of several bamboo products. Today, I would like to present and discuss this topic. China has developed a bamboo industry was about $10 billion per year and has more than 2,000 varieties of bamboo products. Bamboo can be used for building and industrial materials, such as the floor, furniture, decoration, and also for daily use, such as food, papers, and clothes. However, it is still unclear how large the carbon stock of bamboo products in China is, and how much carbon emissions when producing them, namely the carbon footprint. Therefore, from 2011 to 2016, we investigated more than 100 bamboo manufacturers in 4 provinces in China. During the investigation, we measured more than 1,000 logged bamboo cones and traced and measured the whole technological processes of bamboo production. In total, we measured the carbon footprints of 9 bamboo products in 5 categories. The use of bamboo cone can be separated into 3 parts. Cone segment with a cone wall thickness of more than 7 mm will be used for producing the laminated board, the unfolding flattening board, the scrimber board, and then they will be further used for making furniture or floors. The remaining cone segments with cone wall thickness between 5 to 7 mm will be used for producing strips and further used for producing bamboo curtains, mats, and so on. Additionally, some parts of this section can be used for making scrimber boards as well. Bamboo base and bamboo tips or bamboo powder can be used for producing compression board or bamboo charcoal or cleaner. So in general, all the final bamboo products are made from 3 main technologies: the laminated, the reconstituted, and the unfolding and flattening. 5 primary bamboo products with 3 main technologies were investigated in our study. Among them, the unfolding flattening board is produced with the latest high-tech. Therefore, I will take the unfolding flattening bamboo board as an example to introduce how we calculate the carbon stocks and the carbon footprints of bamboo products. Before that, I'd like to introduce the technical process of the 3 main technologies briefly. The first main technology is the laminated technology. The laminated technology is a production process that decomposes the bamboo segment into pieces of particular specifications. Then, the bamboo pieces are dried and glued together after anti-corrosion, mildew, and moth-proof treatments. This technology keeps advantages of bamboo's physical and mechanical properties, such as the small expansion coefficient of water absorption, less dry cracking, and minor deformation. The second main technology is the reconstituted technology. The reconstituted technology contains 2 essential processes, which are defibering and compression. Due to the toughness and the strength of bamboo wood, it is not easy to crush down bamboos. Therefore, before defibering, bamboo segments were soaked in a boiled alkaline solution with a pH of around 9.3. The defibered bamboo strips are dried and glued to form the raw board. The reconstituted bamboo board can be used for making furniture and even building materials. Now, I'd like to introduce the third main technology, the unfolding flattening. I will introduce the technological processes of the unfolding flattening bamboo floor with green bark as an example. As shown in the picture, there are 21 steps for making a piece of the bamboo floor from a standing comb in the field. I'm not going to show the whole detailed process, but only some steps where energy cost, additive applied, and carbon loss happened. From these steps, we derived a carbon transfer ratio for calculating carbon stocks and footprints. The carbon transfer happened when bamboo combs were cut, planed, or trimmed, such as in the steps of 2, 3, 4, and 13. Carbon loss happens in the form of landfilling or burning. The carbon transfer ratio of the products was then derived in these steps and summed up to have a whole carbon transfer ratio for products. By recording the operation and idle operation time of machines, we calculated carbon emissions from power consumption for each step. From the table, we got to know the idle operation of the machine is relatively high in some steps, such as the bamboo opening and softening processes. For steps with lower carbon transfer, carbon emission for producing 1 cubic meter board is relatively high. Furthermore, we analyzed how the carbon transfer ratio of bamboo products changes with comb diameter and technological types. Comb diameter significantly influences the carbon transfer ratio. With a large comb diameter, the amount of carbon transfer to products are higher. This may be due to the relatively high percentage of large diameter comb used for making board. Technological types for producing bamboo boards also influence the carbon transfer ratio. Among the 3 technologies, the unfolding flattening board has the highest transfer ratio. It is 12% higher than screenbar board and 30% higher than the laminated board. With knowing the carbon transfer ratio, the national level of carbon stocks in bamboo products can be derived in 3 steps. In the first step, we set up a relationship between comb diameter and carbon stocks in bamboo products. In the second step, by applying the existing diameter-related Weber distribution function of bamboo comb, we can calculate carbon stocks for any diameter class of bamboo removers. In step 3, the national level of carbon stocks in products can be summed up from carbon stocks in the diameter range of 5 to 15 centimeters. Based on 1.9 billion bamboo removers in 2015 in China, we predicted that a national level of carbon stocks in bamboo products is 319,200 tons carbon per year. Besides carbon stocks, carbon emission during the production processes is another critical factor for assessing the carbon footprint of bamboo products. Carbon emission can happen in some process steps, such as carrying bamboo comb from field to factories by trunks, opening and drying bamboo segments with electricity, and applying glue or oil paint to bamboo board. The additives applied to the bamboo board include adhesive, oil paint, paraffin, and cartoon. The carbon emission factor and the amount of additive applied to 1 cubic meter of the board are essential for calculating carbon emission. Among the 4 additives, adhesive and cartoon in gluing and packing are the 2 most pronounced factors influencing the carbon emission from applied additives to products. By accumulating different parts of the carbon emission and then minus carbon stocks of bamboo products, we know the carbon footprint for a specific bamboo product. For 1 cubic meter of the unfolding flattening bamboo floor with green bark, which is expected to be used for 20 years, the carbon footprint is minus 17.9 kilogram, which means that the studied bamboo product is a low carbon product and even can be called the carbon uptake product. We investigated 9 bamboo products, among which the unfolding flattening floor with green bark and the bamboo screenbar flooring for both outside, outdoor, and indoor use have relatively low carbon footprints. So, in conclusion, we found that comb diameter and production technology are 2 main factors influencing the carbon footprint of bamboo products. Therefore, selecting proper bamboo species for cultivation and intensive forest management is suggested. In addition, high technology in producing bamboo products is also essential, such as the unfolding flattening board. Secondly, our study implied a potentially huge carbon pool of bamboo products. Bamboo products can be a substitute for such as plastic or steel. The low carbon characteristics of bamboo products are expected to strengthen when considering the substitution effect. Okay, above is my presentation, and thank you for your listening. If you have more questions about this study, you may directly contact Professor Zhou with the email shown in these slides. Thank you again.
Thank you very much, Dr. May, for the very interesting and comprehensive presentation. So this study has been done like 5 years ago. I think they measured a lot of samples in 4 provinces because it's the work has been done in my university. So I knew this project very well. So also this outcome has been published, I think, as a book in Chinese. So it's very interesting. Thank you very much. So I think we still have a few minutes for questions, but we might look at the question and but I didn't find.
Dr. Lu, could I ask a question?
Yes, please.
Yes. You have talked a lot about carbon emissions from the process and product side. Have you studied the carbon sequestration during growth? And also, what about underground biomass that the carbon emission may have become a big impact there? Have you studied that?
Yes, thank you, Professor Dan. Thank you for your question. About the carbon sequestration during the growth, yes, in our group, we have did some work and also published, such as Professor Shongxin Zhang. He has published a paper in the scientific report. It's about the carbon transfer from mother come to the newly sprouted comes to support its explosive growth. So now this is the basic idea that the mother comes supporting the growth of the new bamboos, which makes it grow fast. As you know, the bamboos usually finish growing to like 12 or to the 12 meters height within only 4 weeks. So it can accumulate about 80% of the yearly carbon sequestration in such short time. So it was called the explosive growth, which indicates that bamboo has a very large, or the carbon sequestration is very strong. And also we have an Edicoverus tower, which indicated that the bamboo carbon sequestration is much higher than the other ecosystem types, such as the Chinese fir forest or the other similar nearby forest ecosystems. Okay, Professor Dai, am I answer your questions?
Yes, and I would have another question. There's quite a few questions in the Q&A. Maybe I give it to the floor. Dr. Liu, can you check out the?
Thank you, Dr. Dai. So now a few questions come up on our Q&A. So one question, I will pick a few of the questions. One question from Lucy. She asked, can this data be used as part of the process to integrate bamboo into international carbon market? That means this is like a footprint carbon data. Then when we develop the bamboo carbon project for international carbon credit market, this data is good or is to use in this kind of project? I think this question.
Okay, thank you for your question. I think for the moment, from the international level, we don't have an international bamboo carbon sequestration methodologies such as CDM or VCS, but we do have 2 bamboo carbon sequestration methodologies which filed by the National Development and Reform Commission, which was in Chinese. And in these 2 methodologies, we do consider about the bamboo product, the carbon stocks in the bamboo products. And in later, we would like to develop the international bamboo carbon sequestration methodologies, and hopefully our studies can be applied to calculate the carbon credits at the international level. Okay, thank you for your question.
Thank you, Dr. May, for the answer. So now there are many questions coming up, so I will try to pick up.
If I'm not fully answer the questions, Dr. Lo, can you help me just answer some of the questions? Because you are also one member of our group, and you know better than me, maybe.
Okay, now I'm concentrating on the other question, so I will try to pick up a good question for you to answer. I think we still have, I will have a couple of minutes. Let's take a second question. So,
okay.
I think the question from Indonesia, from greeting from Indonesia, besides harvesting the bamboo clumps, any example where places has sealed their carbon stock from bamboo plantation? Have you got the question? The last question. Besides.
Sorry, I beg your pardon. I didn't understand the question correctly.
I tried to pick up the question, the understandable. So can you see the Q&A list?
Oh, I will have to check. Yes, I think.
Maybe we don't have much time. Maybe we take a simple question too, then we can move to the second one. So do you think that book will be translated into English? That's from 80 words, the question.
Yes. Yes, I think yes, I think because carbon footprint of bamboos is widely interested to audiences. So I think we can translate this book to English to help more audiences know the bamboo carbon footprint. Yes, absolutely. I will ask anyway. I will ask Professor Zhou because he is the first author of the book, and I will try to contact. If you are interested in the book, yes, we can discuss through the email.
Okay. Thank you again, Dr. May, for the presentation and for the answer to the questions. So thank you very much. So now we move the second presentation. Thank you.
Okay. Thank you, Dr. Lo.
Okay, so now we will invite the second speaker in our session, Mr. Joshi Jacobus. Mr. Jacobus is responsible for the engaging and understanding the global marketplace's sustainable rating system, codes, purchase policies, and standards for WAP sustainability consulting. I think it's an American company. He is a guest lectures at quite a few universities and have spoken on the sustainable building practice and purchase on the 5 continents in many countries, I think. Also, Mr. Jacobus served as a chairman of the U.S. Milo Committee for ISO 2400 Sustainable Procurement and also for a few other organizations. So his presentation has a long title. It's about life cycle analysis, EPD, GWP, what it will mean, how do we get information, how are they being used. So I think it will be a very interesting presentation because he told us he need 1 hour to give a presentation, but today we only have 20 minutes for you, Joshi. So it's my great pleasure to give the time to you now. Floor is yours.
Sure, sir. Thank you very much for the time and the introduction. That's me, Director of Sustainability, WAP Sustainability. We are the largest independent LCA provider in North America. We do lots of other things, as you see here on the screen, as mentioned. But I want to kind of dive in directly with what started with right? So Dr. Ray just gave a phenomenal presentation on information about carbon coming from bamboo products. The question is, how the heck did we get that information, right? And the answer is life cycle assessment. So I wanted to go into life cycle assessment a little bit deeper so that people understood the process to get the information out, and then show you a tool that is used in conjunction with life cycle assessment that is, again, being used in the marketplace to inform people to help purchase more products. So again, a life cycle assessment is really a very deep dive into an individual product that is made. It starts with things literally coming out of the ground, the materials, where are they coming from, the supply of that material, the shipping of it to the production facility, deep into the production facility, setting up modeling in understanding the actual production. It goes into packaging and waste from the production. It goes into the shipping, into the use phase, the waste that is coming out of that, and the potential end of life of that product. I don't know if the study that Dr. May was discussing took into account end of life. Not all life cycle assessments go fully to the end of life of a product, because a lot of people don't like to think about that a product has a service life, certainly, and that someday it's going to be thrown away, and obviously it's going to degrade. Life cycle assessment also is not phenomenal when it comes to accounting for end of life and the true impact of it. But this is what a life cycle assessment is when you're looking at individual products. Again, this is more the linear look at it, where it's really, again, looking at everything that is impacting. What is our true overall environmental impact of this product, right? Again, to kind of show you what the stages are that we talk about when we talk about life cycle assessment. You typically have a production stage, right? Raw material supply, transport, manufacturing, as I spoke about before. In certain products, there's a construction stage. There's that use stage, which is the B1 to B7 area. Then there's the end of life stage, C1 to C4. Occasionally there is a D. What is required in the marketplace today is what we call cradle to gate must be done, which is the raw material supply information to the manufacturing. So once it leaves the factory, that use stage information and end of life stage isn't always required in information going out into the public for procurement, for example, in things like the lead rating system, which we'll get to in a second. But again, you're going to hear different terms: cradle to cradle, which is a completely circular process or a completely circular look at a product, or again, cradle to grave, which is again the end of life with the product where it actually is thrown away, or again, cradle to gate, which is that initial phase of the product. This is what the modules look like when they come out of a life cycle assessment, right? And on the left-hand side here, you see some information. Again, you're seeing terms here that are different than specifically saying carbon. Obviously, life cycle assessment can grab lots of information for us. Typically, when life cycle information data is put into the marketplace for procurement, they're done with information such like this: GWP, global warming potential, the ozone depletion, the acidification potential, the eutrophication potential, and on down the line here on the left. And you'll see the numbers here, the units in the middle there, and it talks about the numbers over here on the right-hand side with those individual A1 to A3, the A5 levels, and the C1 to C3, and it gives you the individual impact areas and their amounts. So that's great, life cycle assessment data. Most manufacturers do not want to put their full life cycle assessment data out into the marketplace. Number one is because it's their secret sauce. It's literally how they make their product, what they make their product out of, right? It would be like Coca-Cola telling us how Coke is made, literally down to how your factory is set up and some of your secrets like that. So most don't want to put their full life cycle assessment data into the marketplace. There are general studies like Dr. May talked about that are more generalized and not very specific, because again, that's giving away trade secrets for your company. So there is a tool though that is utilized, and it's called an EPD, an environmental product declaration. It's exactly what it sounds like. It is a simple transparency document that declares what the environmental impact of the product is. You need to do a life cycle assessment to get to this, obviously. It also needs to be independently verified by what's called a program operator, a EPD program operator. All of this is laid out in ISO standards, and it is recognized as ISO Type 3 label. The contents of an EPD, and there's just an example over here on the right-hand side. It's, again, that declaration. One of the most important things besides the LCA results that are within the EPD is the declared unit. So if you're talking about bamboo flooring, as Dr. May was earlier, you literally have to say, okay, how much of this flooring are we talking about? So someone can do the math and understand, if I'm installing this much bamboo flooring, excuse me, what will the impact on the environment be through my purchase? It also has other testing results and other verifications as part of it. There is a long development process to this, right? I mentioned the life cycle assessment, but to get to an EPD, you have to have what's called a PCR. Over here on the left-hand side, you see product category rule. Think of it as a standard that helps you translate or filter life cycle assessment data from that really granular, really private information that a company has. It filters that information into the environmental product declaration that can then be third-party verified and put out into the world for consumption and procurement uses. These PCRs, so again, for the bamboo flooring, there is a flooring product category rule. There's one in North America, there's an international one. Those LCA results that were talked about in the previous presentation from one manufacturer can be utilized and filtered through the PCR to create an EPD that can get some of that information to the marketplace. But again, if you're using the bamboo for wallpaper, if you're using the bamboo for other processes or for other product types, they all have PCRs as well, or you have to create one if there is not a PCR in the marketplace. This is what the EPD looks like, a little bit different than just the LCA results. On the left-hand side, you see the direct to LCA results, but they also get kind of collated together and have on the lower right-hand side, just typically, what's our global warming potential if we're using Tracy data? What's our ozone depletion potential, and on down the line here on the right. So that's one of the tools that are being used in the marketplace today is EPDs. The question is, who's driving this demand for environmental product declarations, right? And which is obviously leading to more and more life cycle assessments being done. I also want to tell you why the financial marketplace is driving a huge amount of this. So there are different tools in the marketplace that are being used specifically by the financial investors that are looking at carbon and environmental impact. There's things like SASB, the Sustainable Accounting Standards Board, the Carbon Disclosure Project, which is more about greenhouse gas overall, but obviously your individual product global warming potential and carbon plays into that. You have the Global Reporting Initiative that has been around for a very long time. The Task Force on Climate-Related Financial Disclosures, TCFD. This is climate risk and obviously people's supply chain, which you start to understand once you get into the life cycle assessment that plays into your risk. How will climate impact your supply chains? There's Science-Based Target Initiative, which is having organizations set science-based targets. And then there's actually ratings of public companies like MSCI, which is rating them on their ESG, their environmental social governance. There's also things where individual states here in North America or provinces in Canada, in the United States, the first law put into use, the use of EPDs was Buy Clean Act out of the state of California, where they said, we are going to set maximum global warming potential limits as determined in EPDs for these 4 types of products over here on the left-hand side. Obviously, none of that is in the bamboo realm, but there is a proposed legislation before the Senate in California right now, AB 1369, which would now include gypsum board, insulation, carpet, and ceiling tiles. So they are expanding these categories that they will set maximum global warming potential limits for purchase by the state of California, which is the 5th or 6th largest economy on the planet. There's more though. The state of California started it, as they typically like to do, and there's more and more popping up all around America. You also see up in Canada, there's a couple that are popping up as well in Vancouver specifically, and in Toronto, where they have these Buy Clean Acts that are setting maximum GWP limits for products. Again, that is derived from an LCA going through the PCR to the development of an EPD. There is another law in the state of California that is going through the process that will set that will require EPDs for building products utilized in residential home building. They are trying to ensure that they not only meet their carbon targets in the state of California, but that they help their housing crisis that they have in California, but they want to do it in an environmentally and carbon sensitive way. So they will be requiring EPDs for residential building products. There's also the US federal government. Last December, the White House came out with an executive order 14057. Full disclosure, I had a piece of a part of a mini section that I worked on this specifically around net zero emissions procurement by 2050. This will have the US federal government using EPDs to develop global warming potential maximums for products and only purchasing those products. Obviously, the US federal government, through all its branches, is the largest purchaser on the planet. And they are already starting to put this into use. They are using EPDs to set maximum global warming potential limits for concrete. This has already gone out in March, earlier this year, where they have set very specific kilograms per CO2 equivalent for individual concrete. They're not stopping at concrete and asphalt. They're moving through the products. So again, if you're looking to move a bamboo-based product to the US government or sell it to them, eventually you're probably going to need an environmental product declaration with a GWP on it. Again, there are rating systems and codes in the marketplace. Many people are probably familiar with the LEED rating system. There's also the Living Building Challenge, the BREEAM program, the NAHB National Green Building Standard. There's a number of international rating systems, Australia Green Star, Singapore BCA Green Mark, and there's codes like IGCC, the International Green Construction Code, and ASHRAE 189.1, all have areas, criteria that talk about EPDs and building products. LEED requires 20 individual products to have EPDs from 5 different manufacturers to gain credit. The IGCC allows you to pass materials into a green building if they have an EPD. And the final one, that financial marketplace, again, I want to talk very briefly about. The financial marketplace is going all in on ESG, environmental, social, governance, investing. The largest assets under management organization on the planet, BlackRock, with $7 trillion of assets under management, has started voting against boards that do not have a carbon plan, right? So understanding your product's impact, understanding your carbon, understanding what is going on there is being required in the financial marketplace more and more and more. That's it for me. Again, apologies for how fast that is. Certainly want other speakers to have their time, certainly. This is my way to ask me questions, josh@wapsustainability.com. I'm unfortunately not going to be able to be on the panel at the end, but certainly please feel free to shoot me an email, ask a Q&A here real quick, and I'll be able to stick around for a couple of minutes and hopefully answer some of those in the Q&A. Thank you.
Thank you. Thank you very much, Josh. It's a very informative and interesting presentation. You did it very on time, 20 minutes. Thank you very much. It makes my work much easier. So I know you will leave after this presentation, will not join the panel discussion for other commitment. So we got a few questions from Q&A for you. So I hope you can answer them before you leave. So we saw one question from So Ming. Said, hello, Josh, how can we certify EPD certified by individual consulting firm or association? How can we get a benefit?
Yeah, so an environmental product declaration that is going to be public has to be verified or stamped by a program operator. That's detailed in the ISO standards. some of most people who work in the building product area will recognize these program operators. People like UL is a program operator, NSF is a program operator, ICC Environmental Services is a program operator, or Evaluation Services, excuse me, ICCES. These organizations have been doing product verification and safety for years and years, decades and decades, over 100 years in some case. So they are verifying the EPD before it gets to the marketplace.
Okay, thank you. I think you answered the question. Then the second question is from Gong. He or she asked, which software do you use to do the LCA, or which one do you recommend?
Yeah, so there's about 5 or 6 around the world that are popular or that are used the most. There are more popping up every day. The 2 probably leading ones, certainly here in North America, are a program called GABI, which you get a license for from an organization called Sphera. You also have SEMA Pro. SEMA Pro is another LCA tool that is typically used more in the educational area and universities, but does work really well as well.
Okay, thank you. Oh, there's so a few more questions coming up that I use more your time. So then the third question is, what are the ramifications of EPD on global public procurement and the green investment?
Yeah, as we've seen, it used to be the single attributes were big in the green. So you had lots of organizations say, oh, we're going to buy 20% recycled content paper, or we have recycled content, X, or we're using low emitting material like through Green Guard, or buying energy efficient products with Energy Star. We're moving beyond that now, where we're not just saying what is the product got it in it, but what is the maximum environmental impact that I'm going to allow as a procurement official. So again, the state of California will not purchase above a certain level GWP, global warming potential, on certain products. The US federal government is starting to do that. Other individual authorities having jurisdictions are starting to do that. So EPDs are becoming a trusted resource in global public procurement, and a way for a manufacturer to exchange information about their impact without giving away all their trade secrets, right? What that means for green investments is the financial marketplace is very focused on transparency of environmental impact nowadays, and they want you to have a plan. So if you're able to go in and say, we have this information in the marketplace, hopefully it's increased your sales because you're being more transparent, but it should also help your stock price per se.
Okay, thank you. I think we still have 5 minutes to answer questions, so we'll give you more job to do. So then this question from George Henkel, he's asked, are there initiatives and a way to harmonize all the ratings, codes, etc.?
Yeah, George, that is a great question. One of my full-time jobs is trying to make all these things say the same thing. Occasionally there is people trying to harmonize some of these things, but unfortunately, no. The lead says something different than BREEAM, even though they're asking for the same thing. They ask for it in different ways. The state of California is asking for things in a specific way, different from, say, the state of Washington here in the US. Canada is asking for information in a little bit different way than the United States is asking for information in terms of procurement. So unfortunately, I wish I could tell you that they're all completely harmonized. They aren't always harmonized, but what I will tell you is getting life cycle assessment data, putting it through to an EPD, you will be 90%, 95% of the way to getting to answer all of these different questions. There might be some slight differences that you have to tweak in your EPD, depending on specifically where it might be going. But we can discuss that if need be, but it's really getting to that information, that transparent impact is the first major hurdle that a lot of them are asking for. And then there's slight differences within what they're going to do with the data.
Okay, thank you very much. Now, Josh, last question for you. I want to keep you, not let you leave.
Okay.
So last question is, how does the ESG grading be related with the financial incentives?
Yeah, so the ESG gradings are very interesting. They have come up in the last, 5 or 6 years. I will tell you, I used to deal with marketing and operations people at companies, and now I deal with financial investor relations teams more and more. ESG gradings from people like MSCI or S&P or Moody's that actually grade companies on their environmental social governance plans. Obviously, financial institutions look at that information. We're being told more and more financial institutions are gathering their own data as well and doing their own grading, as they should be, and then setting target stock prices and selling or purchasing based off of those. We also know certain financial institutions are now asking for ESG data for loans. So even if you're not a public company, if you're a private company and looking for financial loans, you can either get preferred funding or you're not even allowed to get funding if you don't have an ESG plan. So we are directly seeing what companies are doing in the environmental social governance area being directly impacting their financial outcomes in the future, not just the sales and return on investment, but certainly from the institutional investor concept.
Okay, thank you very much. It's a very comprehensive, straightforward answer. I think everybody will enjoy your answer.
Thank you, everybody.
Thank you again, George. Thank you. Goodbye. So now we move to our third speakers, Dr. Raja Narayan Mahathi. So Dr. Mahathi served as the director of IPRT, this India Plywood Industrial Research and Training Institute, for 5 years from 2014 to 2019. IPRT is very famous. When I was working at INBA, I knew the India Institute. So in IPRT, Dr. Mahathi led a group of scientists from innovation composite products like specialized plywood, particle board, and medium density fiber boards, etc. Recently, he served as the executive board member of APIFLA, this Asia Pacific Association of Forest Institute, an international organization headquartered in Kuala Lumpur of Malaysia, for 5 terms. It's a very long term. Huh? He was associated with the technical committee of newly commissioned the National Bamboo Mission of India, and for guidance on the mass industrialization. So Dr. Mahathi has a lot of experience on that angular board. This is called plywood. So it's my pleasure to invite the Dr. Mahathi to give the presentation on upgrading value chain of engineered bamboo in construction. So Dr. Mahathi, floor is yours.
Thank you. Thank you, Dr. Lau. And good morning, ladies and gentlemen. Am I audible? Am I audible?
Yes, you are. You can share screen.
Okay. 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 Is it visible now?
Yes,
Yes,
good.
looks good.
Yeah. Good morning. Thank you, Dr. Lau, for the nice introduction. And I'll be dealing with the upgrading value chain for engineered bamboo in constructions. I'm pretty okay. But to start with, let us see what I discussed in the 17th session of United Nations Forum on Forest, because bamboo happens in forest. and bamboo is important because India is from the South Asia, where forests are very important, and bamboo is an important part of the tropical forest happening in this place. So last week, our DG Forest, Sri Chandra Prakash Goyal, he gave a statement in the UNFF17, that is United Nations Forum on Forests. So there he said that India has got 80.95 million hectares of forest, which locks 7,204 million tons of carbon as per the Indian State of Forest Report 2021. And India is also committed to create additional carbon sink of 2.5 to 3 billion tons of carbon dioxide equivalent by 2030, that is as declared in the Paris COP committee of parties in 2015. So India is having a lot of forest, having a great carbon sink, and it is also committed to increase it by 2 to 3 billion tons by 2030. And this is a very important the declaration, and mainly the carbon sink will be enhanced by adding afforestation and doing plantations. And if we are doing afforestation, why not bamboo? So that is the question, or the natural corollary to the declaration of the DG Forest of Government of India. So since bamboo is a strong favorite as a carbon sink, so this should be planted. And if bamboo is planted, then we have to harvest. If we are harvesting, then we have to utilize. So the chain will go on, and it will pop up. It will give a big leg up to the bamboo sector in the country as well as in the global, because it is a big country having a lot of bamboo resources at present. But if the government of India takes up that additional carbon sink in the form of bamboo, it is good for everybody. That's why I am saying bamboo is a strong favorite as a carbon sink, and it should put the bill for the government of India's decisions or the statement or commitment to add carbon sink through bamboo, which I suppose. And for that purpose, there is a National Bamboo Mission since 2006 in the Ministry of Agriculture of Government of India. In a missionary mode, they are doing to enhance bamboo as a resource, as also the utility product. So if National Bamboo Mission is doing that, and Forest Department, Ministry of Forest is also want to enhance the carbon sink by afforestation, so both can join hands, and it will be a gala day or a very win-win situation for both carbon as well as bamboo. But in spite of tremendous euphoria in bamboo all over, there is not much traction. Bamboo sector has not grown in the way it is desired. So that is the statement, or that is the what is happening and what should have happened. And after that, let us move to the next slide. Okay. Here you see Indian bamboo, a strong candidate for climate. Okay. If bamboo is good as a carbon sink, then engineered bamboo is still better, because bamboo releases 35% more oxygen than tree stand. So that's why it is good. It is crucial for O2 and CO2 balance, oxygen and carbon dioxide balance in the atmosphere. So that's why bamboo is good. And it sequesters more 5 to 10 times more carbon dioxide than wood. Then timber bamboo is renewable carbon sinking building material. Having said that, it can be construed that engineering bamboo, being a low carbon solution, caters to negative feedback loop that causes decrease in function to stabilize climate. So it has all the functions, all the properties as a good carbon neutral material. And if bamboo is so, then engineered bamboo will still do far better, and we should all go for it, and which is a climate positive or climate smart option to go for engineered bamboo in our constructions. And having said that, let us see what Indian Plywood EPRIT, the organization I belong to, what it does. The Indian Plywood Industry Research and Training Institute under Government of India. They are research and development body. It is working since 1962, and it's in the agenda we are having research and development, training and education, testing and standardization, information and extension, relating to panel products from wood, bamboo, and other renewable fibers, including agro and forest residues. That we have been doing, and in the form of wood, we have switched over to bamboo also, but wood we are still doing in the form of the plantation wood like eucalyptus and poplar. So bamboo, all sorts of bamboo, and even renewable fibers like coir or the pine needles. So everything, wherever there is lignin and cellulosic materials, we do the panel products out of them. Now let us see how we are doing bamboo. So engineered bamboo, as you see, we have started since the 1980s. In 1985, you see there are generation 1 bamboo mat based, or from this fiber we make the prepare the mat, then we compress them to make a bamboo mat board, and this technology we have commissioned or we have commercialized or given to the industry since 1985 in Kerala state of the country. Then after that we have gone to roofing solution using a platen. We can corrugate the bamboo mat board, and that is called bamboo mat corrugated sheets as a roofing solutions. In 2002, it has been commercialized in Meghalaya, in northeastern states of the country. Then bamboo mat ridge cap, suiting to bamboo mat corrugated sheets, and then bamboo mat molded skin board, which are for the door purpose. So these are all bamboo mat based items. Then coming to generation 2, which we started commercializing in 2011, that is bamboo horizontal laminates, which is good for our flooring materials, flooring tiles. Then bamboo vertical laminates, which are good for furnitures. So all these we have started commercializing since 2011 in industries in Kerala. Then third is bamboo strand lumber, which is from strips by compressing. That you must knowing that bamboo lumber is timber. Since 2014, we have commercialized in Tripura state of the country, again in northeast, which is close to China and Myanmar in the northeastern border of the country. Then beyond that, we are having products out of two very great companies of Moscow International and Dassault, operating from US or the Europe. They are having generation 4 densified lumber or fused bamboo. Densified lumber is from Moscow International, and fused bamboo from Dassault organization. And in generation 5, we are having bamboo infinity or finger jointed beams. So these are latest products which are in the market, but my organization has not done that. It is through others, but for the purpose of better understanding, I have put them here. So let us see from the generation 1, that is bamboo mat based from slivers. So this is a typical bamboo mat. And the bamboo mat board, we take 4-5 mats, then dry them, then put in the resin, PF resin, phenolic resin. Then when we compress under thermal conditions, a board like this will emerge. And if we are corrugating with the platen, then a roofing sheet called bamboo mat corrugated sheet will come. From bamboo mat board, we can have this sort of building or prefab buildings, or we can have also furnitures. And this is Haridwar station, railway station in the northern India. Basing the tropical conditions in the country, we are having railway platforms which are much open, so that there is a lot of ventilations during summer, and people feel good without much expenditure. And there, the roofing is through bamboo mat corrugated sheets. Then let us see bamboo mat corrugated sheets and the bamboo mat ridge cap. Bamboo mat corrugated sheet is a green roofing material pitted against its counterparts like asbestos, aluminum sheets, and galvanized iron sheets. Its energy requirement for production is low. Then it is then energy requirement for production is low. It is highly resilient, low weight, and low thermal conductivity, soothing aesthetic appearance. So these suits all the purpose as a climate material and even for the mass utilization in the country and elsewhere. And this is typical bamboo house we have constructed in Hyderabad, in the southern city of Hyderabad. And entirely the structure, the walling and the roofing is from bamboo mat wood. And inside we have utilized as flooring the bamboo scrimber or the third generation material. And there are some gazebos or some solar huts we have constructed in Delhi through the first generation of bamboo mat wood materials. Then let us see, yesterday there was a discussion about bamboo strips, how it can be used as RCC. Professor Harris from Pittsburgh University was mentioning about that in India it happens that through from the strips we go for construction. Even our ex-DG of INBAR, Professor Chirla Shastri also mentioned about the bamboo houses from mat wood, which I have already shown you. Now let us see how from strips in India we construct house. In Ipriti, there is a Ipriti Trada bamboo housing system. There, the strips, out of strips, we make lattices and we utilize one chicken mesh. Then we apply a cement plaster in both sides. So by doing this, we get a structure like this as per our requirement. So this is a 2-bedroom guest house in Bangalore, which we have done through this technology. So Ipriti Trada is a timber research and development agency in UK. So both Ipriti, my organization, Ipriti, Indian Plywood Industry Research International, as well as Strada, together in collaboration, we fine-tune this technology, which is low-cost, earthquake resistant. In my organization, there is a SEC test experiment we did, and it can withstand the seismicity of zone 5, which is equivalent to 7 in intensity 7 Richter scale. So it is not only low cost, it is earthquake resistant, and it is good in seismic areas. So this serves the purpose in group global south countries in Asia and other places. Next, let us come to the second generation product, which is bamboo strip based. This is a typical strip, which is rectangular and maybe length of about 8 feet or 7-8 feet about that. So this typical strip we get as an interim product from bamboo. And when we compress horizontally, we get a product like this, which is called horizontal laminate, which is good for flooring purpose, for flooring tiles. And there is a vertical laminate. When we join these strips vertically, then the vertical laminate is good for furniture. And these products we have commercialized in the industrial in industries in Kerala since 2011. And now out of that product, that bamboo laminate basic product, we can get so many decoratives. This is the interior model interior of Bangalore International Airport, where we are having the second generation decoratives, which is so aesthetic in appearance. And this is by some Chinese company who have done for Bangalore Airport. Then generation 3, bamboo strand lumber. We all know about bamboo lumber or bamboo wood. And by compression of the strips, after dipping in, after drying and dipping in the phenolic resin, we get beams like this. And this technology, through this technology, we are commercializing in industrial manner. The productions in Agartala, Tripura since 2014. And let us see the linkages or forward linkages of that bamboo strand lumber. So we can have multifarious uses like flooring in Nagpur, Maharashtra. The slick flooring is out of that bamboo strand lumber. Here you can see cladding, wall cladding also in Assam, Raj Bhavan or the governor's house. And you can have wood furnitures like a very good oak furniture or teak furnitures. And in different colors, we can have choice of maybe caramel color or maybe natural bamboo or many colors we can get depending upon the how we are treating the bamboo strips in the just before industrial processing. Let us come to the fourth generation, that is densified lumber or fused bamboo for outdoor decking. These are not our products; they are the products of the densified lumber is extreme. That is trade name by Mosho International, which is a Netherlands-based company, or fused bamboo, which is classic and epic. These are the names, trade names under which they produce, and this is extremely dense product out of modified strips, maybe chemically modified strips compressed to 2:1 after extracting or crystallizing the nutrients by Daso XTR. And here also it is highly densified up to 1200 kg per meter square, attained by hot pressing thermally modified strips. So these are all good for the external decking. But they belong to the other companies, and since 2000, recently last 2-3 years or 4-5 years, they have popularized and commercialized these products. But this is good for G7 or European countries, where this set of products, where they can import bamboo from China, most of bamboo from China, and convert them in Europe or USA and sell it. But my country, we are having a lot of bamboo. We can go for mass or the where our labor force can be utilized properly, and the value chain will be upgraded so that it serves, it will create employment, and also the bamboo sector will grow for the benefit of the country and the economy. And now let us have a comparison about the BMB, bamboo mat based, first generation, second generation, laminates, lumber, and fused bamboo. So resin similar, PF, in case of bamboo mat board, which gives the strength. Laminates, we are having UF or MUF. UF is urea formaldehyde, and MUF is melamine formaldehyde, melamine urea formaldehyde, or PF is phenol formaldehyde. So for the first generation PF, second generation, it is all the three can be utilized, where it is mostly for decorative purposes. And lumber, again PF, and fused bamboo, also phenolic. Then temperature range 140 to 145 degrees Celsius. Here also little less, 10, depending upon the resin you are using, and the cross strip, it is cold. Then we have to go cold pressing we do. So that we have to do again curing in hot chamber. But here, in other cases, since we are doing hot pressing, then only stacking will do for curing in all these four varieties. But in the third one, since it is cold pressing, we have to take it to the hot chamber. And these are the pressures which we apply, about 16 kg per centimeter square. And somewhere it is 2.5, because it is strip, it laminate, we give both vertical and side pressure also. Then there is a compression here, because they are all densified for both cross strips as well as fused bamboo. Then colors, it can be natural here. Here, each as per the glue, there can be many types of color. There are also many types of color preferences in case of lumber and fused bamboo. So they are all for housing, and here it is for outdecking. But laminates is not for structural works; it is more for decoratives and aesthetic appearances. And all for furnitures, may not be fused bamboo. Then decorative, yes. All the three put the bill. Handicraft also written. So let us go to the next slide. Okay, let us come to the main theme, that is the value chain. What is the value chain? Value chain is the full range of activities from conception to delivery, as defined by Michael Porter of Harvard Business School. So if it is full range, then there will be some primary activities like inputs, processing, outputs, marketing, and sales and service. And there are supporting activities like procurement, technology, human resources, and infra. For example, for bamboo lumber, our third generation product, the inputs will be nursery, like we have to get the material, bamboo, so nursery, farming, capacity building, etc. Then processing includes enterprises, machinery, household, group, and self-help groups. Then the outputs include risk mitigation, quality control, policy, strategy, etc. Marketing, sales, and service include traders, small business, consumers. So I think for a bamboo lumber production, we are having all the full range of activities from primary activities as discussed here. Then let us see why we did a upgradation of value chain of bamboo, because unless we upgrade, then we don't get the maximum, we cannot give the maximum value to the customers. And for that, we have to do the value chain management. When there is a value chain, we have already recognized, we have to do the management by organizing all activities as we discussed in the previous slide with analysis and evaluation. Then upgrade after management. Then how do we upgrade? We upgrade the value chain by innovation and improvisation for maximum value with the least cost. That's what the customer wants, because they're the ultimate beneficiary. And when the customer is satisfied, then only the product goes. We can compete with steel, we can compete with aluminum, we can compete with any product. But the customer's satisfaction is the maximum. When he gets the maximum value from bamboo with least cost, then only he will go for, or he will opt for bamboo over and above steel or other competing materials. And so as the chain starts from growing, for example, if we see the chain, how it is working, it starts from going Bambusa tilda, which is the ideal species in my country for strand lumber with QPM, that is quality printing material, which has to be harvested in 4 years. Then we have to, so these are the links in the chain. Then we have to transport. Then there will be cross-cutting, knot removal, splitting, planning. Planning means sizing, making a shape, rectangular shape. Then strip making. Strip from here onwards, we start getting products. So this is the interim strip making. Then dyeing, maybe with colors or by boiling to give a color to the product. Then grooving, so that glue application will move. Then gluing, then drying to 10% of the moisture. Then pressing, curing, trimming, shaping, products making, finishing, packaging, and marketing and export. So all these are links in the chain. And for the upgradation of the value chain, we have to you have to encourage.
Dr. Mahadi, 1 minute.
Yes.
One minute.
Yeah. It is going to go. Thank you. So we have to make innovation at all stages of this value, the value chain, so that we can reduce cost without compromising the quality. In Indian parlance, we call it jugaad. Jugaad means we do improvisation in such a way that all these happen. And for that purpose, we have to go for clustering, because that is the answer. Clustering, development of MSME ecosystem in global south. As we know, what is applicable in G7 or European countries may not be applicable to Asian countries like China, India, Indonesia, where a lot of bamboo, or even Africa, even Latin America, where a lot of bamboo happening. So USA or UK, we can say they are the USA and Europe, we can say they are the countries where they consume bamboo, but they don't grow much bamboo like the engineered products, but they are grown in global south, these countries. Here, we have to concentrate on micro, small, and medium enterprises, which directly go to the people. There is a lot of labor force. They can be engaged, so they get the employment, and bamboo also get a leg up. And for that purpose, for all these micro, small, and medium enterprises, for the first generation, second generation, or third generation engineering products to come up, we have to indulge in cluster development in MSME ecosystem. For what is a cluster? Cluster is a group of similar interconnected enterprises at locations having common opportunities and trade. Then we are examples in my country for plywood. It is Jamnagar in Haryana, Gandhidham in Gujarat, and Perimbapur. where we are having a cluster, maybe at a place there will be hundreds and 500, 100 to 500 companies. They are producing together in different aspects, not the same product. Maybe part of it, what is a finished product for one company, maybe a raw material for another. In a chain manner they are doing. Similar for bamboo, we are having in Agartala, Tripura, and Chandrapur, Maharashtra, like Anji and England in China. People have started doing. Why cluster? For synergy, exponential growth, as well as for improvisation or innovation, which is the key word in the previous slides we discussed. And benefits of clustering, it helps in competition because innovation is the mantra for which, by which we can have exponential growth and where we can give maximum value without increasing the cost. So more and more innovation takes place in informal situation of the clusters having stronger networking. So that's why when they're working together and one is fitting another, so 200, 300 companies working together and they're concentrating different aspects, then innovations is easier and better, and a cluster, there will be synergy and the result will be manifold. So these are how to activate the tips, how to activate value chain and clusters, which is again going to make successful ventures. We have to, these are the different steps that can be, that you can look from my presentation. Then these are success stories. So in bamboo, we don't have much success story in a big bang manner, but in a small manner, we are having like one Mr. Sanjeev Karpe. He has very good this bamboo pot restaurant in Maldives, where you are seeing Miss Paris Hilton took interest in that. She is liking this restaurant. So these are individual success, but no big bang success. Whereas in eucalyptus poplar, which are maturing in 5 years, we have many success stories in India, in Jamnagar, in Parambapur, in Gandhidham, with similar products. But bamboo, we don't have much big bang, but there are some isolated, like Mr. Sanjeev Karpe, the restaurants he made, such success stories are there. But with cluster development, we are getting good signs. Maharashtra state in Western India, Tripura state in Northwest India. So they have started showing early signs. There are massive bamboo plantation, infrastructure development, human resources. There is a political will and business ecosystem. So very soon, I am sure we are going to success in our own way, but not the way Mosho is doing or Daso is doing, but in our own way, will be successful in bamboo story through our National Bamboo Mission. So these are the concluding remarks. We have to promote MSME cultures, bulk and mass production, inclusive growth, green and circular economy, non-polluting, nature-based solutions, sustainable growth. Thank you. Thank you very much. I am open for questions.
Thank you very much, Dr. Mahadi. It's a very interesting presentation. You reviewed all the phases of the plywood and also give your view on how to upgrading the plywood. So there are quite many questions from audience, but because I a little bit overuse time, so maybe I only ask you one question now. Then for the rest question, I hope you and John can address the audience during the panel discussion. So okay. The one question from Susan Locke, she asked, is there any bamboo plywood exported to North America? If so, is there any problems and or challenges? Have you got a question?
Till now, we have not exported any bamboo engineered product. Like as I said, we are having bamboo boards, bamboo mat boards, and we are having bamboo laminates or the what do you say, second strip best laminates, and we are having lumbers. But we do not have much export, maybe because that use, like from bamboo mat board, we can have ecotourism, huts, cottages. So that sort of use may not be there in USA or in the Western countries or in Europe. But definitely, some people told me that there are issues like the environmental norms. Suppose you are using phenol formaldehyde regime, so there will be formaldehyde gas emissions. So that norms, because people in the beginning, they may not come to that E0 or E1 standards. So that may be the restricting factors that they come back in our own country. Maybe they can sell somewhere, but they cannot export because people are very choosy, they're very nosy when it comes to the ports and disembarkation point. So domestic market they fit, but it's difficult to export because they don't have that clout and they don't have that power to compete with Chinese players who are already in USA or in European countries. So it's difficult. And but our domestic market is so large. If they can compete with other products like steel or the aluminium, it will be sufficient because our production is not so much. So if they saturate the domestic market, then it's good for them. And with that strength, they can push for the export. That's what I think, but that has not happened as yet.
Thank you, Dr. Mahadi.
Thank you very much. So now we thank you, Dr. Mahadi, for the answer. So now we finish this presentation and move the second half of the session. So then I will transfer the responsibility to John. John will take over. So John.
Thank you very much, Yiping, and thank you for chairing the first half of this session. I'll just remind everyone that we do have the opportunity to put your questions into the question and answers. We won't be able to get to all those questions today, but we are planning on ensuring that the speakers all receive the questions. And so we are working out the optimum way of getting answers to all the questions. So don't be discouraged that your particular question has not been answered. It will be in due course. And we will let people know as soon as those answers are available and in what format they are. I would like to move on to our next speaker. That is Dr. Edwin Zia Escamilla, who is a senior assistant at the Chair for Sustainable Construction at the ETH in Zurich. That's the Eidgenössische Technische Hochschule. He focuses on the use of bamboo as a strategy for regenerative development. He led the development of life cycle analysis data sets for bamboo-based construction materials and works on strategies for carbon accounting of fast-growing bio-based materials like bamboo. He received his doctoral degree from the ETH Zurich in 2016 and is a member of the Bamboo Construction Task Force of the International Organization for Bamboo and Rattan. He's also a topic editor for the journal Sustainability. And lastly, he's a co-organizer of the International Symposium on Bio-Based Materials and Structures. And so with that impressive array for someone so young, he's going to be giving us a presentation today. Edwin.
Thank you. Thank you, John, for the kind words. I hope you are all seeing my screen.
Yes, we can see it.
Okay, thank you very much. So today, unfortunately, Josh is not here, but I need to thank him because he saved me like 20 slides of my presentation so I can talk about the environmental saving potentials from the use of bamboo in construction. And I like to start these kind of conversations with this cartoon from Monroe. It's now already a bit old, but it's very sane. And I think, and even nowadays, very important that we understand our topics and that we understand our definitions, and suddenly everything becomes sustainable. But why are things sustainable? We need to be very careful on that. And already 12 years ago, I started working in this area and asking myself, okay, bamboo is great, but how great it is. And at the moment, there was not, let's say, quantitative answer to this question. You know, it was, oh, it's great, it grows fast, this, that, but no one could give me a number. And there is where me and other colleagues embarked in this very long journey on quantifying the environmental impacts from the use of bamboo, and of course the benefits from it, you know, and especially in the case of modern architecture, either normal buildings, expositions, but more importantly, and where a lot of my work been focused in social housing and post-disaster construction. Josh did a very comprehensive introduction to LCA, and I just need to add a couple of small remarks. This is, of course, the most accepted methodology to assess this kind of impacts, and of course to answer these questions that we are posing. And I think the most important part, the application that Josh was mentioning is very important, but also the LCAs, they produce information. So the end product of an LCA is information that we can use in decision-making processes, either selecting or improving processes. So that is very important, and something that we need to clarify all the time, because that a product at the LCA doesn't make it sustainable, doesn't make it environmental friendly, doesn't make it good. It's just we understand the production process, and hopefully the person responsible is taking the appropriate decisions to achieve the objectives they want, either reducing consumption of resources or energy or their carbon footprint, whatever. So the LCA show us the commitment towards some improvement process. That is very important to keep in mind. The other part that stay a bit away in the presentation of Josh is that, especially for alternative construction materials, especially in bamboo among them, we have a big challenge in terms of on the quality of the data that we require to do these kind of assessments. We have very diverse production processes. In long years of experience, almost every factory works different than the next one. We are confronted with a large number of medium to small producers. And very importantly, there's very, very limited financial support to develop this kind of data. This is very time consuming and very expensive. So we, in collaboration with the Eco-Invent Association, INVAR, the University of Zurich, at my chair at the ETH Zurich, we decided we need to find a solution, and we need to propose ways to bridge this gap, because it cannot be that only the guys with the money can have an LCA. So we embarked in a very long journey, finished partly last year, and we managed to develop the first and include the first data sets for LCA in Eco-Invent, that is the largest LCA database in the world. So if you want to do an EPD for bamboo-based products, then you need to get or makes your life easier if you get a software that uses Eco-Invent as database, like you mentioned CIMA Pro, OpenLCA, NotGAL. So this is somehow our contribution to solve this problem. And I also need to remark here is that the data we provide is not the ultimate word. As we say, I already said, each production is different. So we need to, and we present this data as a framework. In the case, if a researcher or a producer, someone wants to work with bamboo and the LCA and has no idea on bamboo, they have some values that put you in the ballpark. But if you're a producer and you know your values, you know your species, you know your electricity, you can take this data sets and modify it and then have your own very specific LCA. So currently, and since September last year, we have 42 data sets already available. And we are still working and in big discussions looking in the data sets for engineered bamboo products, which is a very, very long and tedious discussion, because these are products that are very special, and in the terms and the way we do LCA, very different. So, and unfortunately, it's a very small group of people trying to push this. So we hope we will get there. And then, as I said, why we want this data? Why how we use this? And I want to today show you two case studies where we use LCA to understand the impacts of the application of these materials. And we have in this study two different applications, one for single-story houses and one for multi-story houses. And in both cases, we have, for the first case, consider the houses being built with the engineered bamboo, with the cement bamboo frame technique, or the bareke technique, and concrete hollow blocks, bricks, concrete. And for the multi-story, the only application we can do is with engineered bamboo. Then we have engineered bamboo and comparison to concrete and bricks. In this case, we look at Colombia as a case study, mainly because we have very good georeference data from the production sites of the materials and products, especially cement and steel, which are very important in any calculation that we do in LCA of buildings. And as already mentioned, we use the software OpenLCA, the database EcoInvent, and the evaluation method is IPCC 2030. So there's the International Intergovernmental Panel for Climate Change. And we look at the differences that also the transportation of these materials bring. You know, because we have, on the one hand, we have different production efficiencies coming from different factories, coming from different productions, but also from different locations we can transport these materials to the building. In a very quick summary of our results there, we see, first of all, the first 4 columns. We have the single-story housing solution. There we see bamboo, the bamboo cement frames, the bareke, engineered bareke. We obtain close to 60% environmental savings. And here we are looking only at the carbon footprint. So we're not looking at stored carbon. I will talk a bit about it later. Those just from the production of the materials and the transport, bamboo for single-story houses, that is the best option that we have. In multi-story housing, the last two, we have even a more interesting result, because we have a very efficient use of the materials, but also we have a much lighter building, which rebounds in a much smaller foundation. So not only we are having materials that have lower carbon footprint, because of the lighter weight, we end up with a whole system that has much lower material demand, especially concrete. As I was mentioning, for us was very important the question of transport, because is almost one of the few endless discussions. What happens if I bring it from here to there? So, and it's important to remark that it's not only a question of the distance, but also the amounts and the weight of the material that you are transporting. So we use this in LCA, we typically use the unit ton per kilometer, metric ton. And from here, we have the results from both. And we see in the full line, the single-story houses. And you see even at the longest ratio of transport weight, we have a significant environmental saving. So, which means, first of all, we could transport even further the materials. We will still have a lower environmental impact than what we obtain with conventional construction materials. And similarly, in the case of multi-story housing, then the engineered bamboo is very difficult to build. It's super efficient in the use of materials, and as a whole, as a building, you will have way less material and therefore also less way materials to be transported. So that again tells us that in this case, we could transport the materials even a longer distance than what we studied, and we still have a significant reduction in the environmental impact or environmental saving in comparison to what we would obtain with conventional materials. And this is one part of this big equation, and we question again, okay, this is great, this is good, but why is this not happening? What are the barriers there? And this is an ongoing discussion because the field is changing rapidly. Also, thank you, Josh, for explaining that. Some time ago, investing in alternative construction materials was a no-go field for most of institutional investors around the world. And now, even private companies are openly committing to invest in this kind of material. So we are also reviewing all these calculations that I'm sharing with you today, because the landscape is also changing significantly. And we depart from the very clear idea that the parties from the COP21 agreed that we need to enhance carbon sinks and reservoirs, including forest. That is a nice part. So it's not only forest. We have things that go beyond that. And of course, you have seen it already in the presentations today. Bamboo and the bamboo forest is one of them, and the other are bamboo products with long lifespans, like buildings. And we are looking for different alternatives. It's not only biomass. We can also do improvements in cement production. We still need cement. We still need concrete, but we don't need to use it for everything. So it's a bit of a problem. So we look at these two options: limestone calcite clay and engineered bamboo, and how these things compare in terms of investment, and what are the different returns that we can obtain from these materials. Been discussing with some cement companies that, and they say my number was very conservative for the initial investment on an ordinary Portland cement. So it's much higher. Nevertheless, what is very interesting here is we see that the time horizon for the return on investment is very similar. So assuming that the markets are working and that the construction industry is going and that the materials are used, then we see that for the three options, the ordinary Portland cement, the LC3 cement, and engineered bamboo, we have. So there is no argument that you will not have a return or that the time horizon is good. So that is a very first interesting result we have there. The other thing that we calculate, and is very important, is when we start producing more cement, we only have more emissions into the atmosphere. With the LC3, there is a significant reduction on the emissions to 70%, but only with bamboo we can establish this kind of storage and sinks. And this is we are working on this because this is a static view. We need to have a dynamic view on this because these are carbon cycles, so they are moving all the time. Just from this starting point, we see there's a significant contribution from the bamboo plantation. So the connection, this intangible connection between the plantation and the buildings is very important. But also, we need to be aware that just planting the bamboo is not doing the whole thing. We need to look in how to use it. And then we look at also very important, especially in emerging economies, developing countries, how many buildings can we build? And there is where we have the challenge. If we need to build fast, the mineral solutions have an advantage. If we don't care about anything else but just build fast, their bamboo is a disadvantage. But, and I think that we need to stress a lot, the number of jobs that we can create by doing this investment is way, way larger, and in indirect and direct. So it's not only investing to produce materials, to produce buildings, we are investing to create jobs. And finally, we take the interesting road and say, okay, what would happen if we would take an investor has $136 million in the pocket and say, okay, what if I put this money into bamboo? The carbon capture and storage goes in the other direction. So we have a benefit significantly larger than what we do with cement. But, and that's the big but, we need to be aware that it's a large land that we need to have in one way or another dedicated to the production of bamboo. Because once we start the plantation, we need to have it there, first for storage bamboo, CO2, but also to produce new resources to keep the production going. So this is a compromise that we also need to be very careful. It's not for free. And of course, the mineral solutions are very, very small demands in terms of area. And we should not forget that. And as I was mentioning, to invest and just put a plantation, as some companies are claiming or committing to do, is nice. But we need to think that these plantations need to be connected to a productive value chain, to a sustainable value chain. Because otherwise, someone is just putting bamboo forests in the backyard of someone. So who is going to take care of them? And who is going to do it? We are working on that. We're currently running a master thesis on this subject because it's very important to come up with the numbers and solutions. Just to close, and we like to call it, bamboo is a regenerative construction material. What does it mean, regenerative? The more we do it, the better it's going. The more we use bamboo in construction, the more carbon is stored in the real environment and the more carbon we remove from the atmosphere. So that is the sense of it. But also, we create new jobs, we create new opportunities, and we create solutions that are affordable for the people. And this can only happen when we have sustainable value change. This needs to be connected from the forest to the delivery and housing and beyond. And this is the commitment and convinced that bamboo, among all the bio-based alternative construction material, is the material to spearhead the transition. Because it's the one where we can literally see growth and literally see how we capture CO2 in the built environment and how we move towards net zero built environment. And that we can do it now, which is the most important part. And with that, I thank you for your attention.
Thank you very much, Dr. Escamilla, for a fascinating presentation. There are quite a few questions. We've got time maybe for a couple. One of the things that really struck me was the slide where you showed that there would be a significant land requirement. And I noticed that there have been several questions, not only to you, but to former speakers as well, about the issue of monoculture plantations. If you were to plant large areas with a single species of bamboo, what's going to be the ecological ramifications of that?
I mean, like anything in life, it depends, because bamboo is native to many continents. Mm-hmm. So bamboo is actually a native species. So if you are planting it there, so in its nature state, bamboo is monoculture, and it allows some mix. I don't know, in the picture you can see sometimes there's one tree or the other. So you are extending a natural environment. If you are planting the local species and so on, If, and we have this discussion this morning, you bring, for instance, now there are people in Portugal and Italy planting bamboo. That raises the question on biodiversity, But again, there's always a but.
Yes.
What they are doing is reclaiming degraded land. So bamboo allows you to reclaim the degraded land. The native species, you cannot do it. So what are the compromises? And I think in general, when we start thinking of bamboo, we need to think on what are the compromises we need to do. Because bamboo is great, but like anything in life, it has limitations. And we need to understand what are those and what are the compromises we're ready to make. Because it's great construction material, but we need a lot of land dedicated to its production in comparison to mineral construction material. So are we okay with that? Is the land large enough to be able to pack that? So it's very case specific. But
it sounds like a very similar argument that there is with fast-growing tree plantations. And essentially, if you've got large areas of degraded land, and we know that globally there are large areas of land that have been degraded quite badly, that's eroding. If we can put plantations in there of bamboo or trees, then we're going to be improving that environment. Yep. And so maybe we should be talking more about the co-benefits associated with establishing these large plantations.
Definitely.
Because those are...
Yeah, sorry, go ahead.
Okay, I would move on to another question. This is from Aji Santoso in Indonesia. I am wondering which species of bamboo can give the greatest benefit for industrial and carbon capture and storage. And does it depend on the region where that bamboo is from?
In terms of carbon capture, we have, in a very simplified way, on the one hand, the speed of rotation. So how fast can we extract material and regenerate it? And the other factor is then how durable are the products we can produce with that species. So the big challenge is we have beyond 1,600 species, and that we can say we know a lot is like 5 species. So it's very difficult to answer, because I will tell you the ones I know because they are the ones known. But if we look in this relation between the speed of rotation and the durability and the life service of the product, then you start getting somehow a good understanding of the potential.
Thank you. It sounds like there's a lot of research still to be done.
Yeah.
Okay, so we're going to thank you very much for that presentation, Dr. Escamilla. We're going to move on to the next presentation, which is actually by 2 individuals who are going to be presenting together. The first individual is Lucas Oshun, from the Regeneration Field Institute in Ecuador. He's the proprietor of Los Arboleros Farm, which is an agroforestry and bamboo operation in coastal Ecuador. So he may talk to some of the questions we've just been talking about. Lucas also directs the Regeneration Field Institute, which is a bamboo construction, disaster relief, and agroecology organization that was launched after a 7.8 magnitude earthquake destroyed much of coastal Ecuador back in 2016. He works as a bamboo supply chain consultant and supports the efforts of NGOs and researchers in Ecuador related to questions about conservation, inventory, and the utilization of bamboo. He will be joined by Tom Goodham, who is the biomass project manager for the Innovation Accelerator team at UFP Industries. Tom is an 18-year veteran of the building materials industry and has overseen product development, R&D, manufacturing operations, and office operations teams for Resource Fiber LLC, Trinity Bamboo LLC, and TerraGrand Fine Bamboo Flooring. So huge experience in the bamboo industry. I will hand it over to you two.
Thank you. Hello, everybody. Thank you for that introduction. And thanks to all the organizers of what has thus far been a fascinating and highly informative event. So I think as we've been identifying throughout the series of presentations over the past 3 days, that the first step to realizing our aspirations for bamboo to help us green our economies, ecosystems, and built environments is to develop viable materials to displace the environmentally degrading products that are most commonly used these days. As a next step, it'll be really important and really close after that first step, it'd be really important to identify the whole supply chain of how we're going to have enough material should we have the success that we hope to have with broad adoption of these materials in construction materials markets in the West and hopefully eventually all over the world. I'm very inspired by the progress that we've seen presented by BAMCOR, Lambu, MOSO, newly also innovations from Bamboo Nations and advocates and scientists such as Chunping and Suzanne. I'm presenting on the day, Tom and I are presenting on the day about carbon emissions and circular economies. But I'm going to encourage us to think a little bit more broadly and also think about the whole host of ecosystem services provided by bamboo, as well as social and economic factors. So since 2010, I've been leading diverse forest restoration, leadership training, and conservation advocacy work here in Manabí, Ecuador. We reforested more than 80,000 trees in the tropical dry forest and through community projects, and also led the reforestation of mangroves throughout the estuary here in the central coast of Ecuador. After a 7.8 magnitude earthquake in April of 2016, our focus shifted to bamboo construction, basically seeking to address the urgent need for shelter and to address the need for using more seismic resistant materials. Bamboo is a great option because it's abundantly available and renewable, as we know. And so these are some images of the destruction after the earthquake. We began buying bamboo and curing it and set up a construction team to be building first shelters and then permanent homes. So this took us into many bamboo producing communities. We set up treatment operations for the bamboo as well, and began curing bamboo with the goal of providing as many jobs as we could in the post-earthquake economy. So we learned through trial and error and cured a lot of bamboo that was used in the construction of houses for our projects. We had workshops, we had like prefabrication centers, makeshift centers, and we went about learning as much as we could about bamboo with the support of local architects and various experts here in Ecuador. So there's a large demand increase in the time after the earthquake. for disaster relief applications, for the redevelopment of ecotouristic projects. Farmers needing more income in the post-earthquake economy started harvesting more bamboo, also just to make space for new crops that they were planting. The Ecuadorian government fast-tracked a building code here also, which led to more broader adaptation of bamboo. Understanding the current bamboo market and Ecuador as a case study, it's important to look to the data that the Ecuadorian Ministry of Agriculture publishes. We have trouble verifying this data, but they say that there is an estimated 600,000 hectares of bamboo in Ecuador. And I figured even if we have 1/10 of this quantity, Ecuador has a significant potential to participate in the emerging global bamboo products industry. We have a research group that has begun remote sensing projects here led by Dr. Javier Haro of McAllister College, who is developing an algorithm to use remote sensing data to identify where bamboo is. A large majority of the bamboo suitable for construction available in the Americas is in Ecuador and in Colombia, and is naturally occurring Guadua angustifolia. A Peruvian market continues to grow, importing an estimated 5 to 10 million 6-meter pieces from Ecuador annually, primarily used for low-value applications such as scaffolding or bracing for other types of construction or temporary construction. Bamboo traders purchase entire groves and typically severely over-harvest, thereby reducing the Guadua angustifolia's capacity to regrow. In some cases, the goal is simply to permanently clear the bamboo to make way for other agricultural crops. We're experiencing a process of destruction and loss of bamboo stands here in Ecuador due to overharvesting for these markets. As well, some farmers are just burning bamboo to clear land for the other agricultural activities. For most landowners, bamboo is not perceived as having much of a commercial value. Though yet to significantly materialize, industrial buyers from North America and beyond are intensively investigating the Latin American supply chain options, and few are beginning to import. This is some pictures of our former warehouse in Alabama for Resource Fiber. I was leading the development of their global supply chain up until the company went bankrupt in the latter part of last year for primarily financial reasons. But these are slats that we imported from Mexico. In the upper right-hand corner are railroad ties that we're submitting for testing. So what does sustainable management look like? With Guadua, it means harvesting half of the mature 4 to 6-year-old culms annually from a bamboo grove. Bamboo groves need a full canopy for photosynthesis to continue, for optimal photosynthesis to continue to provide energy for the rhizome network and to make new culms. Overharvesting can lead to empty spaces within the grove, causing bamboo to bend into the empty spaces, leading to curved culms, which are no good for most types of construction or manufacturing. Maintaining paths open through the understory is important for access, and then leaving cut bamboo sealed just above the nodes as to not have it soak with water and rot the rhizome network. Sustainable management is important not only for the future productivity of groves, but also to allow the bamboo to continue to provide the ecosystem services such as slope stabilization, riverbank erosion mitigation, biodiversity conservation, water storage. Much more could be said on this and should be said, but our time is limited. So measuring the ecosystem impact, measuring impact of ecosystems and communities, a great deal of academic and commercial research goes into the development of engineered bamboo products for construction, but comparatively little effort is made to research how to optimize the relationships with supply communities and bamboo ecosystems. Due to this deficit and anticipating a growth in the bamboo industry of the Americas, in 2020, we created the Regenerative Industries Think Tank, a collaborative interdisciplinary group looking at case studies here in Ecuador. We're currently implementing bamboo remote sensing inventories, socioeconomic surveys, bird, primate, and plant biodiversity surveys, and much more. But much more attention is required on this subject. So if folks are interested in collaborating, we are always open to host visitors in our meetings. Here is a picture of Tamara Britton checking out some bamboo, and she's an anthropologist researching the relationship between primates and bamboo and people, and how we all use those resources differently. Here's some research we're doing of mapping, taking samples and measuring culm diameters. So the balsa industry provides an interesting example. Balsa is a core material for the wind turbine industry. 7 years ago, balsa was not perceived as having much value in Ecuador. Ecuador produces 95% of the world's balsa. There's a high demand, and severely fluctuating prices have led to the clear cutting of much of the naturally occurring balsa. International buyers work through intermediaries, don't interact directly with farmers, so aren't particularly clued into the environmental and social realities of the externalities of their supply chain. During upswings of price, large quantities have been planted on formerly forested lands, clear cut for the new crop, especially in the Amazon, and also in degraded pasture, the latter obviously being a much better way. So will bamboo create a similar dynamic? This is perhaps a cautionary tale for us. So the future demand for bamboo, a significant scale of adoption of laminated engineered bamboo products will obviously lead to demand increases of the raw material. How will the currently unsustainable practices of harvesting and sale and management of bamboo here in Ecuador, as an example, how will this change if there's a large demand increase? Mature Dendrocalamus asper in plantations in the Americas, as far as I know, under 2,000 hectares, and managed guadua plantations are estimated at a similar range. Much more common are naturally occurring stands, not under any management. In Colombia, there's much greater oversight than in Ecuador. Construction materials market is highly competitive, and for these new companies, there's significant pressure to purchase low-cost bamboo. Using the whole culm, manufacturers typically require the bottom 3 to 6 meters of each guadua angustifolia culm, 6 to 12 meters of each Dendrocalamus asper culm for slat-based manufacturing due to thicker walls in these portions. 10 to 14 meters of each guadua culm is essentially wasted by only using these bottom portions. The cost of this waste would be, in most all cases, shouldered by the farmers. As presented earlier by Ting Ting, the industrialization of bamboo in China has succeeded in large part due to the state support developing secondary markets to be able to utilize the whole culm. The bottom portions are used for laminate manufacturing, while the upper portions, thinner walled sections, are used for really all kinds of products, but including fuel pellets, chopsticks, toothpicks, etc. So smallholder sourcing or industrial farming. It seems to me that there'll need to be a combination of both of these approaches. In the short term, we'll need to look to the naturally occurring groves because it's where the vast majority of the bamboo is. I believe in bamboo as a sustainable material of the future. But will the new bamboo manufacturers manage to do right by bamboo farmers, by bamboo ecosystems and their bioregions? Will over-harvesting, working through intermediaries, be the norm in Latin America? It is important to look at examples like China, India, Kenya, Colombia, Philippines, Vietnam, to name a few, and how they've managed or mismanaged their bamboo resources when in the face of demand fluctuations. Lucy Binfield at UBC is doing admirable work researching and organizing information regarding the global bamboo industry's impact on communities and economies. Latin American governments have much weaker institutions and regulations than China. So sustainable harvest protocols must be prioritized by manufacturers themselves. Truly sustainable supply chain development. True sustainability should include socioeconomic fair business practices. Companies will need to invest in sustainable harvest training, audits, certifications, and more. Will startups with limited capital invest in these relationships? Is there support out there for the international development agencies or NGOs to support manufacturing companies? The answer is potentially yes. I've worked with INBAR, COPADE of Spain, the Spanish International Development Agency, and others who maintain strong goals to support smallholders to participate in industrial bamboo supply chains. Redefining the North-South trade relationship. Could there be a market in Latin America to manufacture finished products for export to America and Europe? Is there potential for domestic and regional sales of these products? Cost of labor, bamboo itself, transport, and facilities are going to be much lower. The disbursement of available bamboo across many small farms represents a logistical challenge, but also an opportunity to grow horizontally beneficial supply chains. By creating an ongoing value, demand can contribute to safeguarding bamboo ecosystems. A surge in demand could also wipe out the bamboo. The jury is still out. Will engineered bamboo products gain a substantial market share in the coming years? Will companies invest in sustainable supply chains? Will social and environmental justice be prioritized? I encourage us to think beyond carbon sequestration to other ecosystem services provided by bamboo, as well as social and economic factors. We can all play a role as scientists, engineers, architects, builders, investors, environmental advocates, and as consumers. How can we develop this industry to live up to its tremendous regenerative potential? That's it for me. Here's a picture of our house and education center in Chone, Manabi, Ecuador. Some of our local Guadua bamboo and a cabana that we also have for visiting researchers in case any of you would like to come and visit. For any questions or collaboration ideas, you can reach me at the email listed there. And to check out more about our education program work, please visit regenerationfieldinstitute.com. Thank you again for the opportunity to present today. And from here, I'll turn it over to Tom.
Thank you, Lucas. And Tom. Can't hear you. You're still muted. There we go.
Hi, good afternoon. My name is Tom Goodham. Thank you so much, Dr. Lowe, the UBC team, Suzanne, Professor Dai, and John, for the opportunity to speak here today. It's truly a gift. Let me just get this set up here. Present from the beginning. All right, so my presentation for you today is really about manufacturing products in the United States. For the first, 18 years of my work in the field of bamboo, I was always working.
Do you mean to share your screen?
Oh, I'm so sorry. Gosh darn technology, right? See, I make everyone else look good. Okay, can you see my screen?
No, I think you need to go to your Zoom window. And
I
then right in the middle is that share screen button.
That's in green. Green button.
That is what I pressed.
Yeah, you hit that one, and then you just need to pick your PowerPoint or PDF. There we go.
All right. Again, my job is to make everybody else look great and
Perfect.
Technologically savvy. Okay, here we go. All right.
Tom, I have to say that we meant to have like a total 20 minutes for the two of you. So if you have a full presentation, can you run it through very quickly? Thank you.
I will do my best. Thank you. So my focus is really about manufacturing products in the United States. For the first part of my career, all the manufacturing I did was close to the source of bamboo, and we exported finished goods to where we were making the sales. In this case, with Resource Fiber, we chose to manufacture in Alabama in the United States. So the real challenge there was not our ability to manufacture a product. The real challenge was our ability to source materials and what that actually means to, the carbon impacts to manufacturing and to the cost of these goods. So we focused on manufacturing a material which you're all familiar with, strand bamboo. It's an amazingly strong material. It's made out of a very few number of ingredients, bamboo fiber, adhesive, and more labor than you think it will take. So how do you make strand bamboo? At least how did we do it? We needed bamboo. We worked with Guadua and Gustifolia. This was all material that was essentially, we called it pre-processing in Ecuador, for example. The skin and pith were removed. the material was split into strips about 3 meters long and then shipped in 40-foot containers. And, I guess, any opportunity to mention this is valid. So shipping a material from Ecuador to the United States is about as inefficient a process as can possibly occur. And as far as carbon emissions, it's terrible, right? This bamboo, the other ingredient is a phenolic resin, and it's a great material. It's durable and waterproof. It's low emitting as far as formaldehyde emissions, and it cures at about 212 degrees. So the bamboo is crushed, and I think this is really important. Because we're making strand bamboo and not dealing with the strips, it's important to have the phenolic resin as incorporated with the bamboo raw material as possible. And I think this point's really key, and we can get back to it a bit. Adhesive is applied to the crushed fiber. Some folks merely coat the outside of the fiber with an adhesive. I think it is open to discussion as to whether or not other techniques, such as using techniques used in wood preservation, so perhaps using pressure and vacuums to try to incorporate the adhesive into the resin. I think the important factor here is just use enough adhesive. There's no reason to use more than is necessary for the required performance of the material of the end product. And then, of course, fiber is dried to a moisture content of about 12 to 15%. And then the coated fiber is pressed into billets and heated until it cures. At Resource Fiber, we used a radio frequency press, and we made billets. So, things that look like railroad ties, essentially. Because of the end use of some of our materials, I believe we were going to evolve to using platen style presses, so making 4-foot by 10-foot sheets of strand bamboo. I think as we talk about being careful with our materials, anytime you don't have to cut something, you're saving kerf and you're saving carbon and lowering your raw material cost. So what's the end result? Really, strand bamboo it's a super material. We all know that. Its MOR and MOE capacities are excellent. That's awesome. So why isn't everyone manufacturing strand bamboo in the United States? Really, it comes down to the cost of the bamboo. If you're trying to make a material that competes directly with domestic timber, you're talking 16 to 20 cents a pound for Douglas fir, and bamboo imported from Ecuador is more like 60 cents a pound delivered. And and it still requires additional processing. So that's a ton of money for a raw material, which really should be inexpensive. So can't we pay less for bamboo from South America? No, and we shouldn't try. And Lucas, thank you so much for, all of your efforts. Lucas, I think we should all be listening to him and his experience as we talk about what it takes to actually use the word sustainable in a meaningful way. It is not sustainable to go to Latin America and expect to lower your cost by negotiating too heavily in the raw, for the raw material. The fact is that people there need the money, and although the negotiation may be successful, it will harm the long-term ability as a group to obtain bamboo from these markets, because people will clear cut it. They will not do sustainable management. So the solution isn't, if you're going to manufacture in the US, the solution is not negotiating heavily in Latin America. The solution is creating the correct products for the US market. So what's the solution? We need to acknowledge that if we're trying to compete directly with products made for pine or fir, we can't, and we shouldn't even try. So what we really should be doing is, if you want to try lowering your cost from Latin America, maybe we should try utilizing more of the culm. Maybe we should figure out through the crushing process, or through how we prepare the material for use. Maybe we can figure out a way to use a greater length of the culm, more like an OSB type material, or how we make glulam type beams with overlapping of fiber. So we need to use more of the material, and we shouldn't try to manufacture products that are at a real tight margin. It just doesn't work. So another solution is, frankly, grow bamboo in the United States. Anytime you're importing raw materials over a tremendous distance, it's a problem. It's just the reality of it. So there are a number of species that can be successfully grown here in the United States. And, our research shows they can be, successfully and profitably grown and sold for less than $200 a ton, which is like 10 cents a pound. So compared to 60 cents for import to 10, that's what we need to do. Are there significant challenges as far as mechanical processing? Yes. Will using local bamboo reduce carbon emissions? Absolutely. Can it be done? It totally can. I think through the use of chemical methods to peel the bamboo, such as caustic soda, to using mechanical methods to harvest the bamboo. These are all things that do require additional research, but it can totally be done, and it should be done. For US markets, unless it's a real high-end product that competes, with very other expensive items, then we shouldn't do it. And there you go. So try to make it quick. And thank you so much for your time.
Thank you very much, Tom. I'm going to suggest that we not have any questions because we are running out of time. I do want to allow our last speaker his time, and then we will have a shortened final panel discussion. So sorry, Lucas and Tom, the great presentations, but we are going to have to postpone the questions. So finally, we have as the last presenter in this 3-day marathon, Sol Rodriguez, who is from the University of British Columbia in Canada. Sol is a bamboo and timber engineer at the forefront of sustainable building revolutions. He has worked in mass timber and bamboo projects in Canada, Mexico, and the Caribbean, and he established a community-managed bamboo social housing project for the NGO American Nicaraguan Foundation and Casa Congo Conservation in Nicaragua. That was partially funded by the Hilti Foundation and Habitat for Humanity. He's currently doing a Master of Applied Science in the Department of Wood Science at the University of British Columbia with Champing's group. And he is leading a multi-industry alliance project that is funded by the Natural Sciences and Engineering Research Council of Canada. That's focusing on the creation of novel engineered bamboo wood products for structural building applications in Canada. So over to you, Sol, for the last presentation.
Perfect. Thank you very much, John, for that introduction. Can everybody see my screen?
Yes, we can see it.
Looks good.
Okay, fantastic. I'll just keep my video off so there's better signal via my voice. But first of all, I just want to thank the University of British Columbia and the World Bamboo Organization for putting this together. I think in order to be good stewards of this fantastic building material, we need more events like this. So I applaud the effort greatly. I would like to start by acknowledging that today I'm presenting from the traditional unceded and territory of the Musqueam people here in Vancouver, in British Columbia. And I'm currently affiliated to the University of British Columbia as a graduate student, and I'm also director of Casa Congo Conservation NGO in Nicaragua. So throughout this conference, we've been hearing great insights. Pablo, on the first day, he was talking about the material scarcity problem the world is facing. Edwin today talked about the potential for bamboo as a carbon negative building material and job creation avenue. So I'm hoping that today in my presentation, I can show that bamboo is actually a material not of tomorrow, but a material of today. And I want to show that through my lens. I want to share how I see bamboo and how bamboo can become rapidly mainstream building material in the world. My background is in timber engineer. I've worked in Vancouver as a structural mass timber engineer, and also been fortunate enough to work in amazing projects around Latin America with leading bamboo design firms that have empowered me to see bamboo differently. So today, there's a couple of global challenges we're facing. And first of all, like, we need to acknowledge that the earth is collapsing. We're in a state that the climate crisis is exacerbating a lot of problems, both at an environmental and social level. And indirectly, there's a strong housing crisis. A lot of people live in inadequate housing live with inadequate housing, not only in the developing world, but also in the developed world. And lastly, there's a lack of research and development, especially in the developing world. So what I want to open up for discussion is, do we think bamboo can be a new global value chain? And this was shown yesterday by another presenter, this map. So I dropped in some bamboos and added some arrows to this map to show how bamboo can become a great building material around the world by creating a strong value chain for it. I see bamboo through a mass timber engineering lens. I've been fortunate enough to be at the forefront of this building revolution in Vancouver. A couple of years back, UBC had the tallest wood building tower. Brock's Commons is a 18-story tall wood building made from a series of products that belong to the mass timber family. And I'll talk a bit more about those products and what we can learn from them, and how we can see bamboo advancing through similar steps of how the mass timber industry has advanced greatly over the past years. I see bamboo from a bioconstruction lens. I've worked with Arquitectura Mixta, who's a leading bamboo bioconstruction design firm based in Mexico. And they work both with bamboo poles and bamboo slats. And now I'm studying bamboo a bit more from an academic lens at UBC. And this has opened a whole other realm of building products, which is how I think this engineered bamboo building products can be adapted to a North American market. So a little bit about mass timber. I'm not going to spend much time here, but on the right-hand side, you're seeing a building located at the University of British Columbia. This is the Sears building, the Center for Innovation and Research and Sustainability at UBC, and it's built completely out of a post and beam construction made from glued laminated timber. So why am I talking about mass timber here? The reason is because I want to invite everybody to follow this industry, to learn about the current trends and development that are happening within this industry, the technological advances that are happening, and see how bamboo can be adapted or introduced into this fast-growing market in order to accelerate the transition of bamboo as a mainstream building material. We know that mass timber products such as glue laminated timber, cross-laminated timber, and laminated veneer lumber, they're highly renewable building fibers. They have the potential to be carbon negative building materials, and they allow for fast, efficient, and cost-effective prefabricated building solutions. And bamboo can be part and meets all those criteria as well. So the other lens through which I see bamboo a lot is through a prefabrication lens. I've been studying and working in this industry for a couple of years now. This slide is adopted from a lecture from Professor Guido Wilmers from the University of Northern British Columbia. But I really like it because it summarizes what are the different levels of prefabrication. And essentially, there's 4 basic levels. We can start at the component level, where we're talking about light frame trusses, framing packages, or heavy timber components such as glulam. Then we have the panelized components, which is prefabricated walls. Level 3, which we start getting into volumetric solutions. And then level 4, which is actually prefabricating entire houses off-site and dropping them into site. So here are just some 4 quick photos. I tried to grab from the internet the best pictures available there to illustrate what are the different levels of prefabrication. And again, the mass timber industry, the wood industry is really accelerating and growing with this industry. So I believe that the bamboo industry similarly can really grow fast through this. So now I'll transition into a prefabricated bamboo solution that we designed for Casa Congo and the American Nicaraguan Foundation in 2020. Just a little bit of the overview of the project. We built 20 prefabricated bamboo homes in coastal region, in the coastal town of Astillero, Nicaragua. Each house is 50 square meters. It has 2 beds, 1 bath, one living room, and 1 roofed patio. It has decentralized wastewater treatment systems and also rainwater collection systems. You can see the gutters here. They tie back into a rainwater collection tank towards the back of the house. It takes us 3 days to prefab and assemble the house from top of concrete to roof. And as Michael Ramage said, 1 kilogram of bamboo stores about 1.8 kilograms of CO2. Each of this house is built out of 150 bamboo poles. A bamboo pole about 6 meters long weighs roughly 25 kilograms. So quick math calculations, this house just in the primary structural building materials stores about 6.7 tons of carbon emissions equivalent. And above all, like, we're trying to tap affordability. So when we're designing this process, we tapped into a process that allows us to build efficiently, fast, per the local context. And we're able to deliver the houses today at $250 per square meter. So how do we want about this process, and can it be replicated? So there's 2 ways, there's 2 steps in order to deliver a prefabricated bamboo house. There's a pre-project phase that takes roughly between 4 to 8 months. The most important part is step 1, stakeholder consultation and product design, understanding the local context, understanding the local skills, understanding the local need and the client's need. And from there on, we go into bamboo supply chain development, which involves a lot of capacity building, both at the forest level, at the treatment level, at the fabrication level. Step 3 involves the construction of a microfactory in order to deliver the homes. And step 4 is essentially training and putting it all together and doing a dry run before the project starts, ensuring we can nail down what we're promising and delivering. So then the project phase, as I said, is about 3 days per home. So for 20 homes is 60 working days. And I'll explain the project phase in detail. But before I do that, I just want to share the housing pillars that this project got designed based on after a community consultation. So essentially, the housing pillars are establishing community managed supply chains, where we create social enterprises in order to create green jobs along the bamboo value chain, all the way from sustainable forest management to timber bamboo processing and construction. The community really wanted to see their places built out of natural local materials, and create new skill sets in order to diversify livelihoods. And also, we decided to tap into the creation of agroecological gardens and ecotourism as accessories to a bamboo building house in order to create a strong, holistic housing solution for the local communities. These are just some of the results of the surveys that we did in the community. We spent a couple months just learning what was the community's average income, their expenses, their ability to pay mortgage, their willingness to live in a bamboo house, their willingness or actually their perception towards bamboo, their willingness to help build bamboo homes. And based on this, we came up with the product, which is the prefabricated bamboo cuna house. Cuna actually means house of nature in Mayan Yucatec. That's why we decided to use that name. And the main building blocks of this house are two things: bamboo strips and bamboo poles. We have been seeing here in this conference that bamboo can be engineered fully, but for the context we're in and for the budget that the project permitted, this was the best solution available. It's a process that requires fairly low tech. It's easy to learn, it's easy to transform. The quality control, quality assurance processes are fairly well known for these two bamboo constituents. So we decided to create a prefabricated panelized bamboo housing solution. Here you're seeing the house from a bird's eye view, and you can see a bunch of P's and numbers. This indicates the number of panels the house utilizes. So the Cuna house is made out of 12 panels. And for every panel, we had a series of shop drawings indicating the exact length, the number of bamboo combs, the number of bamboo strips, the openings for windows. So what we actually did is that we designed a factory to be able to produce these panels in an offsite environment and prefabricate the panels according to the specs. And then we transported the panels to site and erected them. So here you can appreciate on the right-hand side, the finished panel, and on the left-hand side, the shop drawing of that panel. Now, I just want to do a quick overrun and show you the factory layout. This is actually a 20,000 square foot factory. Very low investment, like dirt floor. All we needed was a roof, some working tables, some basic tools such as drills, table saws, automatic nail guns and staple guns. But it's really about applying the principles for prefabrication and taking like previous case studies and designing for a fast and efficient production system. So I'm not going to go into the details of the factory. I'm happy to answer questions later and go through it, but it's very basic here. We have the main prefabrication tables on the top, and on the bottom, we have all our equipments from circular saws to make strips, to chop saws, to cut bamboo to length, and then storage space for the finished panels. And on top of this, I want to mention that we needed roughly another 20,000 or so square foot just to store all the bamboo that was required to deliver the 20 homes. So now going into the process, I'll just do a quick run through of the project phase. It starts with earthworks and foundations. We did some grade beams and a slab on grade, and you can see that the anchors where the bamboo panels are anchored and fixed for rigidity and also like from lift off are fixed directly to the foundations. So there has to be very, very good coordination between the concrete trades and the carpentry trades in order not to have errors there. And from there on, we go into bamboo dimensioning and panel fabrication. This is our Cuna microfactory. This is our station where we have our chop saw, and this gentleman is just cutting bamboo to length. You can see in the back all the bamboo stored. So we have raw treated dried bamboo on one side, and then we have our storage for the dimension bamboo, and we're collecting all the offcuts here nice and orderly for future use in joinery or other things. These are prefabricated station. This is our prefab station. So you're seeing here is a jig. This wooden board is actually a jig. It's a 90-degree jig that allows us to just deploy in a fast manner the panel. We have here Maurel and his colleague is working on the assembly of the panel. You can appreciate here that we have the opening for the windows. So we pre-install all openings. Very important to work with wood wherever you have windows and doors, because bamboo in its natural state is not straight. So that facilitates a lot the integration of windows and doors into the panel. Very important not to forget transportation logistics. Know your roads, know what equipment you have available. I mean, we're not working with any cranes or things like that. Luckily, bamboo is a very, very lightweight material, so it can be handled between a crew of 3 men, loading and unloading. So again, talking about context-based solutions, know what equipment you have available and understand the local context well when you're going about this. Now going into the on-site assembly and roofing installation, the house goes up in about a day and a half. All the panels are erected. First, columns are dropped into place, beams are dropped into place, and then we drop all of the framing for the roof. Here in the transverse direction, we're dropping wooden slats, which allow for an easier and more straight and leveled installation of the roof. So that's the Kuna prefab process. The last step is actually installing electrical, plumbing, and rendering. The houses were rendered with a mortar paste into a metal mesh. So from the outside, actually the house doesn't look like a bamboo home, which some of the people in the community were looking for that more like concrete-like or masonry-like construction approach. And this is our final product. So I just want to close by saying that all this was possible due to a community that really believes in bamboo, a community that wants to adapt bamboo as a mainstream building material in their community, and would like to see their community thrive in a sustainable and equitable way. Also, we received a lot of support from UBC, from Hilti Foundation, from the American Nicaraguan Foundation, from Habitat for Humanity, and from a bunch of my colleagues that are working in the mass timber and prefabrication industry. So I just want to give a big thanks to that. And to wrap up, I just want to open a general question to the community and ask, is a bamboo house better than a concrete home? And it's a tough answer to, it's a tough question to answer. And I don't know if I have an answer now, but I know that throughout this project, we've collected good data along the categories of embodied carbon, structural safety, fire safety, affordability, the speed of construction, the resiliency of the supply chains, equity, diversity, and inclusion. And we've been collecting very meticulously data around our male to female work ratio, the worker's wage is paid as a percentage of the total cost, the green jobs created along the value chain, the tons of raw material available in the region, metrics like the distance of the raw material to the project location, which all contribute or can help us answer these questions. So I'll just leave that question there for us to discuss in the panel. And since we're running short of time, I'll just leave it there for now. Thank you very much, everybody, for listening and allowing me the space to be here. And I hope that together we can disrupt the market. I just want to close by saying that all of the challenges that we've been talking about today in terms of life cycle assessments, adhesives, manufacturing, efficiency, cost, those are challenges that the mass timber industry is facing. Those are challenges that the construction industry in general is facing. So it's not unique to bamboo. It's good that we're talking about them. It's good that we're thinking about them at an academic and research level so that we can put bamboo out there as a good option in order to help decarbonize the construction industry. Thank you very much.
Thank you very much, Sol, for your presentation, and thank you for keeping to time. We have maybe time for one question for you, and then we'll move into the panel session. I'm just looking at the questions there. Maybe Jörg Henkel's question might be the easiest to answer. Can you share some idea of the investment costs in setting up your factory, the microfactory?
Yes. So the investment, I mean, it's a tough question to answer because you need to consider the cost of the land, the cost of preparing all that. Like, luckily, my organization, Casa Congo, already had a lot of those assets in the community. So the cost of setting up the factory, the structure itself, and the cost of buying the machines is not much. We're looking a rough order of magnitude between $70,000 to $50,000 if you know what you're doing. And if you have also adequate access to good machinery and support along that side. Okay, thank you. There are other questions, but we will get to those after the conference, and so all the speakers will see the questions that were thrown up. I would like to move to the panel discussion now for the last 14 minutes that we have. So if the speakers could turn on their videos and mics, it would be good. I see there's still a few of you left. There's a couple of people had to leave, and we knew that. So I'd like to start off with a general question to you all, and it really is related to the objectives of this event, which we were trying to work out. How do we look at the challenges of bringing bamboo into the huge potential market that exists in North America? What do you feel are the biggest challenges in terms of introducing bamboo into housing, into other major uses like bridges, utility poles, railroad ties, and others, wherever it's from, whether it's from China, Indonesia, South America, Africa? There is this market here in North America. The money is here. What are the challenges? I'm not going to pick on anyone, so jump in, whoever wants to go first.
Okay. Like in any country, your first barrier is on standards and codes. If your building codes do not allow the use of bamboo, you have no market for it. So that is the first big challenge. And afterwards, of course, you need to look at your value chains. But because it's not only in terms of, can I build or not? It's also, can I finance these things or not? You know, there's also limitations in terms of the financial institutions, how they look at it. And not only for bamboo, timber, for instance, the question of fire safety is one of, and not only fire safety, the insuring for fire safety is one of the biggest challenge and barriers for bio-based materials I'm talking from experience in Europe, but I don't know. I can imagine you will have a similar situation in the US market.
Lucas, you said that you had worked for a company that no longer exists. That sounds like you've direct experience of a challenge.
Yeah, we were, Tom and I both worked for Resource Fiber, and we were really leading a lot of the product development innovation. David Knight and Ann Knight and Marcia Folsom over the past decade created some amazing products and cultivated a lot of interest in the market. And we had to get through the final stage of ICC testing in order to get those products into the marketplace. And we fell few $100,000 short of being able to complete that vision. Money and runway in order to have enough time to complete what you need to get done in terms of the testing and certification process is one of the big ones. in our experience, the interest on the part of architects and developers was tremendous. And we talked to some engineers that commented to us that they'd never heard of a product that actually didn't exist yet in the marketplace that had such a high degree of serious interest, because we didn't actually have the ICC specs or have the a formal spec sheet for our products to be able to market them. But there was already a number of developers and architects who were enthusiastic for including our products in some pretty large scale building products. So I think that speaks to the enthusiasm on the part of the building industry to explore and use alternatives. On the supply side, just to answer the same question, I would say that there has to be a phased approach. So you don't really know exactly how quickly products will take off in terms of the scale of demand. We looked at one project with Resource Fiber in LA. They're thinking about using our bamboo nail laminated timber decking product. And I think for that one project, I think if I'm not wrong, it was something like a 60,000 square foot project, and it was going to be like 70 or 80 40-foot containers of bamboo fiber for that one project. And so assume you get 2 or 3 projects like that, and you don't want to turn down those opportunities after a decade of developing your company. And then it becomes a question of capacity to intake that much fiber and throughput of the factory. And do you have your suppliers up to speed to be able to act quickly? What is the lead time to increase the capacity of providers? Those all become really important questions really quickly once you have viable products in the marketplace. And so most of the bamboo available is naturally occurring. As of right now, there is some bamboo in plantations, assuming we're sourcing from the Americas, that is. And so you have to have sort of a tiered approach, I think, where it's creating collaborations to source from smaller holder farmers, defined as ranging from 10 to 100 hectare range, and then scale up to maybe your proprietary plantations over a 10-year time period. But there's a lot of lead time that you need for establishing new plantations as well. And so you're going to, in my mind, have to be sourcing from some of the smaller holders in the short term, transition towards some larger plantations that maybe you can help establish, and then potentially, eventually, even domestic production in the United States in places like South Florida that have been addressed in this conference. But what comes first? The demand, establishment of the plantations. It's a tricky equation to work out, because here in Ecuador, we've had experiences. There's 1,500 hectares or so of Dendrocalamus aspera that was planted because of the promise of an industry that was going to be developed in Quito that never really materialized. And so you have a lot of people with a lot of bamboo without a lot of demand. And so that's fortunate for those looking for a lot of bamboo now, but it hasn't been great for those landowners in terms of an investment over the past decade and a half since they planted it. So.
John, can I jump in there?
Please.
I think like one of the biggest challenges the bamboo industry faces, and like any new building product like industry, is like the adoption of that product as a mainstream building material, right? Typically, like a new building product has like a bell curve, the very early stage, then the mature phase, and then like it goes out of commission. And I think like the mass timber industry right now, it's on that rise and going to the bell curve, and hopefully like concrete and steel are coming out or are going to become less utilized. But we really need to get the product right. If you want to disrupt the market, you need customer adoption, and you need to understand what are the challenges that the customer, the client in this case, is facing, be it the builders, be it the developers, be it the designers, the engineers, and design products accordingly to the needs that they have. And that goes back to a lot of standardization. Do we have code compliance pathways for engineered bamboo products? Can we adopt existing standards? For example, here in Canada, a lot of the CSA standards for glue laminated CLT timber products are well defined. Is there avenues for bamboo to tap into those existing standards to accelerate the adoption of them and guarantee those high quality performance properties that engineers are looking for and building code officials are looking for when certifying projects. Also, we can take like project-based design approaches. It doesn't have to be that Bamboo is registered like under codes. If we take more of a performance-based approach per project and put demonstration projects out there that we show that with Bamboo we can build, it can be done well, it can be done fast and affordable as a demonstration project. And then with the scalability promise, we can tap into developing the global bamboo industry.
Thank you for that. I was fascinated by the examples of the modular construction, and I'm wondering whether such modules, it would be more efficient to manufacture them close to the source of the bamboo and then transport them, or is it more efficient to take the raw material and ship it, say, to somewhere in the States, where you then have a manufacturing facility, but presumably with a lot higher wages and other direct costs?
I think it all comes down to money. As Sol mentioned, getting the product right is kind of step one. There needs to be a demand for a product, and then we as manufacturers can address that demand by creating a product that has appropriate performance characteristics. But then if the product is too expensive, regardless of how high quality the product is, there just won't be an uptake. There won't be a demand for it, because when it gets right down to the very end where they're saying, okay, we can specify this material or an equivalent, probably made of traditional dimensional timber. If it costs significantly more to use a bamboo product, it won't receive broad adoption. It just won't happen. So I think, it's really finding that delicate balance of, here's a need for something, here's a product that meets that need at the correct price. And, as you suggested, John, that likely means, hitting that correct price either means growing bamboo in the US, doing whatever you can to lower the cost, or perhaps additionally manufacturing that product closer to the source of the raw materials, so you're shipping as little waste as possible.
If I can jump in that comment from Tom, I think beyond that, it's important also to look at civil society, that there are materials that are doing very negative impacts to the environment and to all of us. Mm-hmm. And there are other materials that have positive impacts. And there is no evaluation for this additional service that we are providing, that the materials provide, and the environmental burden from many of the mineral-based materials is just taken by us as society. So we need also to start thinking that we cannot just take this this burden that is dumping to us and then say, oh yeah, it's a cheap material. No. We also need to move the conversation outside of this scope of the pricing of the materials towards this idea of there are environmental services, but there are also environmental burdens, and those responsible for them should also take responsibility, and not us as civil society being the ones paying for clean air and the water when it's clearly coming out of the chimneys down there.
Thank you. I just wanted to ask Dr. Mohanty, since he's rejoined us, what is your view about potentially manufacturing modular materials in India and exporting them to North America? It's a long way.
Yeah, making in India and exporting to North America.
Yes.
Yeah, it is a long way, as you said rightly. Because India, we have a great market ourselves, and we have to compete with traditional classical products like steel, aluminium, glass, whatever. And bamboo industry is not so strong. They are still in the infancy. If you say that we are in third generation trend lumber, we have not yet gone to decking material or densified, but Mosho International or Daso exterior they're doing. So we are not in that level technologically, but that strand lumber what we can send, still we have not saturated our market, but sending to US and satisfying the environmental norms there will be a little difficult, because your environmental norms are very stringent in comparison to India and other the global south countries. There we are a little relaxed. We are not totally oblivious about the norms, but it is not as stringent at Europe and US. So that will be the biggest challenge or the stumbling block for Indian companies when they are still struggling to have a foothold against the classical materials whichever is available. So first we have to break the challenge that we should conquer in our own country, in the home domicile. Then only we can think of overseas. So that stage is not over, that we have not a very sound foothold, or the business-wise that the economic muscles is not so strong as yet. Maybe over a period of 5 years or 10 years, they can think of, but not at the moment. It will be too ambitious to go and do business in US or Europe.
Okay, thank you for that answer. I think we have heard over the last 3 days that there are many challenges, but also huge opportunities with bamboo. And I think the message I'm going to come away from this conference is that there is a huge amount of enthusiasm. There is a lot of interest. There's a lot of research questions still to be answered. And there's a lot of commercial questions that still need to be dealt with and addressed. There are also issues of building standards and other standards that need to be done. And we need to look really carefully at some of the life cycle aspects of bamboo. And I noticed there were some questions about that from the audience. So I'd like to bring this 3-day webinar series to a close. I'd like to thank my co-organizers, Suzanne Lucas, Ian de la Roche, Chumping Dai, Hal Hinkle. I'd like to thank UBC and the World Bamboo Organization and our partners, INBAR and ICBR, who I think are partly responsible for the very high attendance that we obtained. It's way higher than we were anticipating. I'd also like to thank the Zhejiang Agriculture and Forestry University, because they basically laid out the finance for this, which enabled us to have the free registration. I realize that for many of you, the timing was awkward, but unfortunately, the timing is going to be awkward for someone somewhere in the world in these types of seminars. However, we will be making all the presentations available. We're just going to do some editing first so that we have, it looks a little bit better than it would do if it was just the 3-hour blocks. And we'll also look at the questions. We'll pass those to the speakers and try and get those answered. So if you did ask a question and it wasn't answered during the conference, you will get an answer. So keep an eye on the website, and we will let people know when the material is available on the web, and you can then go back to individual presentations, or if you just had to go to bed or it was too early in the morning or whatever, you'll be able to access it. So thank you everyone for your attention. Thank you for your engagement. I've never seen so many questions in an online conference. Even today, we had a lot from, I don't know, we've got 127 participants right now and 55 questions. So that's almost a question from every second person. So huge engagement. Thank you very, very much. We do hope to organize further conferences. Won't be one for a little bit, but maybe on an annual basis. And we look forward to your participation in those. And thank you very much for your attendance.
Thank you.
Chumping, do you want to say something finally as the chair?
Not really, John, you said it so well. And I just want to thank everybody. And this is really giving us a lot of confidence going forward. whether it's a future event or move forward the big agenda that is to convert natural grown bamboo as a building material for our market here. Thank you.
And Suzanne, the last word?
Last word is just thank you to everyone, and let's meet again.
We will do. So thank you, everyone. On that note, we will close the webinar.
Thank you. Bye-bye.
Thank you, everybody.
Thank you. Bye, everyone.